In this session, we're going to talk about differential calculus, also known as differentiation, or what we call derivatives. Now, you can differentiate using, just basic rules that we're going to talk about. But in this session, we're going to differentiate using first principle. Okay? So, let's just talk about the basics. Let's say you have a function f of x is equals to, let's say, 2x, let's say to the power 3. So how do you differentiate such an expression? Okay, so they ask you to find let's say dy dx. Okay, so this is a general expression of differentiation, or they can ask you to find f prime of x. So this is just the same. So in this scenario, our f prime of x will be equals to, or the value of x with relation to the value of y. Okay, so what are you going to have? So according to differentiation, you're going to multiply the power with the constant. In this case, the power is 3. You're going to multiply it with 2. Then what you're going to do is, to the power is that you're going to subtract 1 from the power, and let's just do that. So if we multiply 2 and 3, that will just give us a 6. So I have 6x. Then to the power, I'm subtracting by 1. So 3 minus 1. So therefore our f prime of x in this case is just going to have 6x to the power 2. So this would have differentiated. Okay, let's have another example. Let's say you have y is equals to, let's say, 2x to the power 3 minus 4x plus 2. Okay, so what are we going to have? You are going to have, in this case, you're going to have dy dx. Okay, you are going to write this, or you're going to write dy with respect to the letter that you are given. What do I mean? Okay, if I've got v is equals to, let me say, t something, I'm going to say dv over dt. Okay, so you're writing your letter with respect to what you're given in the equation. So that's what you're going to do. So in this case, we have dy with respect to x will be equals to, so you know that the power will multiply with the constant in front of the letter. So we're going to have 6x to the power subtract 1, we have a 2, minus the power, in this case, you know that x has the power of 1, it's going to multiply with our 4, and to the power we subtract a 1. You know that we have x has the power of 1, to that power we subtract 1, okay, plus. Then the differentiation, or let me say the differential of a constant, it will be a 0. How does it become a 0? Let's say you have 2, and you're going to assume that this 2 is attached to a letter. Okay, let's assume that the powers of x are decreasing. If this is x squared, this is x, it means the other one will just be, so we'll just assume that this is x to the power, let's say 1, this will be x to the power 0, because the powers of x are decreasing. So allow me to assume that. So what we are going to have, it will be 2x to the power 0 in this case, this one. Why? Because to the power x to the power 0, 2 x to the power 0, you know that it is a 1, right? And when I multiply 2 and the 1, it will just be a 2. That's why I'm writing that. But now if I'm going to differentiate this expression, what am I going to have? I'm going to multiply the power with the number in front of x, which is 0 multiplied by 2, that will just be a 0. Then to the power, I subtract a 0. So I'm going to have x to the power 0, then I'm going to subtract a 1. Okay, so you know, whatever I'm going to get in the bracket multiplied by 0, whatever that number is, it will still give me a 0, right? That's why I was saying the differential calculus of, or the differentiation of a constant is 0. So I'm going to have a 0 here. Allow me to write a 0. Then what do I have? Therefore my dy dx will finally be 6x squared minus 4 x to the power this will be x to the power 0, right? Okay, therefore now our dy dx will be equals to 6x squared minus you know that any number to the power 0 is 1, so 1 multiplied by 4, that will just be a 4. This will be our answer. So that is very, very important for you to know. Let's solve the last question just for illustration's sake. If let's say we got v is equals to, let's say 40 squared, let's say plus 5t, let's say plus 7. What are you going to have? The way we are going to differentiate this one, you're going to say dv over dt, okay, will be equals to, we're going to have 8t, okay, plus 5, okay. So that will be our answer, because you know that the constant gives us a 0. Okay, now you can differentiate even using these, you know, a simple basic formulas, okay. However, you can also differentiate using first principle, which we're talking about in this in this session. How do you differentiate using first principle? Okay, so if you are differentiating using first principle, let's say y is equals to f of let's say y is equals to, you know that y is equals to f of x, right? Okay, y is equals to, it's just the same as f of x. Let's say now you're trying to differentiate dy dx. Okay, so according to first principle, the limit as h is approaching 0, let's say of f, so according to first principle, this is the formula x plus h minus f of x over everything over h. I don't want you to forget this first formula. This is the formula that we'll be using when we are solving, you know, or when we are differentiating using first principle. I don't want you to forget this formula. Let's have an example. What if they ask you to, let's say our question is, let's say y is equals to x. Then they've told us to differentiate using first principle. How are we going to solve that? So we're going to say dy with respect to x, or dy dx, will be equals to the limit. Allow me to write the formula first. Always write the formula first. Okay, so you have f x plus h minus f of x, the whole expression over h. So how are we going to solve this? We're going to say the limit as h is approaching 0, where there is you know, where there is x plus h, or where there is x, I'm going to replace x plus h. Okay, so what am I going to have? In this case, I'm going to have x plus h minus, then I'm going to replace the whole function. The whole function f of x, it is just x. Okay, so minus x, everything over h. Now we're saying that this limit h is approaching 0, so wherever there is h, I'm going to replace 0, and I can just do justice. I've got x and negative x. These ones are they are adding up, and because they've got different signs, they'll give me a 0. Therefore, on top of h over h, so I have the limit as h is approaching 0. I have h over h. H over h, they can divide, then they'll give me a 1. So I'll just remain with a 1 in the overall expression. Now, what did we say the limit of a constant is? We said the limit of a constant is just equals to a 0. So in this case, our answer, the limit of a constant, it is that same constant. That's what we said. Okay, pardon me for that. So the limit of a constant will be just that constant. In this case, it is just 1. So our answer will be 1. Let's have another example. Let's say they've asked you to find the limit of, let's say f of x is equals to, let's say, the square root of x plus 1. Now this is a common potential exam question. So how are you going to find the limit? So you're going to say f prime of x is equals to, you write your formula, the limit as h approaches 0 of f x plus h minus f of x everything over h. That is a 1 mark for you in the exam. Now what are you now going to do? You do your replacements. So you're going to have the limit as h is approaching 0. Now wherever there is x, we're going to replace x plus h. So let's just do that. So I'm going to have the root, x is my first thing, so I'm going to replace that x with x plus h. So let me do that. So I'm going to have x plus h, then I have a plus 1, so don't forget your plus 1. So I'm going to also put a plus 1. That's the first expression. Then I have a allow me to wrap this. This is big. Okay, now that I've got that, I have a minus. F of x is the function itself. The function is equals to x plus 1. So I'm going to allow me to replace that. So I'm going to put x plus 1. Okay, everything over h. Okay, now that I've reached at this point, I'm going to rationalize the numerator. Okay, now if I rationalize the numerator, what will happen? What do you get when you multiply a number by its conjugate? Okay, that's what you should ask yourself in this scenario. What do I mean? Let's say you have a minus b. This is multiplying by its conjugate. Let's say x, a plus b. You know that this is just the same, it's the same as the difference of two squares, or it is the same as a squared minus b squared. Okay, or it is the same as a minus b squared. Okay, so now that we've got this, that's what we're going to do even in our expression on top. Since we are rationalizing it, rationalizing would mean we're going to multiply both sides, both on the numerator and the denominator, by what is on top. So we're rationalizing the numerator. So I'm going to have x plus h plus 1. Now instead of having a minus, I'm going to have a plus. I have the square root of x plus 1 over, I'm going to have x plus h plus 1 plus the square root of x plus 1. So that is my expression. Now I've said what is on top is just the same as this, squaring that. So let me just square what is on top, because we're multiplying by the conjugate. So what am I now going to have? I'm going to have the limit as h is approaching 0. So I'm going to square this, and I'm going to square that. That's how I'll solve what is on top. Now if I square that, everything that is on top, you're able to see that only the roots are going to cancel. So I'm going to remain with x plus h plus 1 for the first one. Okay, then I have minus x plus 1. Okay, over, we've solved what is on top. Now let's solve what is down. I have my h multiplying by x plus h. Okay, there's a root actually, so allow me to put the root. So the root of x plus h plus 1, then I've got a plus the root of x plus 1. This is in brackets like that. Now that I've got that, what do I do? If I solve this expression which is here, there's a minus there. Okay, what am I going to have? Okay, so if I solve that, there's negative x plus 1. What am I going to have there? So you know that if I've got this expression negative of negative x minus 1, so that is what is here. So allow me to write that there. So when I distribute the negative here, I'm going to have negative x. Allow me to write it this side. Allow me to wrap this side. Okay, I'm going to have the limit as h is approaching 0, x plus h plus 1. When I distribute the negative of negative x negative 1, okay, everything over h, the square root of x plus h plus 1 plus the square root of x plus 1. That is the expression that I have now. Now I can simplify what is on top. Here there's a positive x, here there's a negative x. This will give us a 0. So this and this is a 0. I have a positive 1 and a negative 1. This will also give me a 0. Therefore it means on top I'm just going to remain with h. Now I've got an h and an h down. So this h and this h can also divide. Therefore on top I'm just going to remain with a 1. And here I'm going to remain with a 1 multiplying by everything. Therefore the limit of h is approaching 0. On top I have a 1 over I'll have the square root of x plus h plus 1 plus the square root of x plus 1. Okay, now that we've got that, what are we going to do? Now that we have got this, we can replace where there is h, because h is approaching 0. Where there is h, we're going to put a 0. So therefore now the limit will be equals to the limit of h as it is approaching 0 of x of 1 over, here when I put a 0 where there is h, I'm just going to remain with the square root of x plus 1. Then I've got a plus there, so I have a plus the square root of x plus 1. So now how do we now finally simplify it further? Now if you simplify that expression further, we now have the limit of h, the limit as h is approaching 0, we'll have 1 over, now the square root of x plus 1 plus the square root of x plus 1, this will just give us 2 the square root of x plus 1. So this will be our final answer. Let's solve the last question. Let's say you have f of x is equals to, let's say, x squared plus x. So how are you going to solve this one? So you're going to say f prime of x, you can write your formula, the limit as h is approaching 0 of f x plus h minus f of x everything over h. That is our formula. Now let's solve. So f prime of x will be the limit as h is approaching 0. Now wherever there is x, we're going to in the first expression we're going to replace x plus h. So let's do that. So I'm going to have x plus h where there is x squared. So I have x plus h, then this is squared, right? Okay, plus again there's another x, so I'm going to say x plus h. I'm done for the first expression. Now there's a minus here, so allow me to put the minus. So this will be a minus. F of x is the whole expression, which is x squared plus x. So allow me to put that x squared plus x, everything over h. Okay, so now we can solve. So the limit as h is approaching 0, now when we solve this, what are we going to have? I have x plus h, then there's a square outside. You know that I'm going to square my x. I'm going to multiply 2 multiplied by x and 2 multiplied by h. That will be plus 2xh. Okay, then again I'm going to square the h at the end. We say this is a shortcut way of solving such an expression. So allow me to just write that. So I'm going to have x squared plus 2hx plus h squared for the first expression. Now remember I've got an x plus h, so I'm going to write it plus x plus h. Then on the far end I'm multiplying by the negative, so I'm going to distribute this negative. I'm going to have negative x squared negative x, everything over h. Now is there something that we can cancel here? Okay, let's see. I've got a negative x squared and I've got an x squared. This will give us a 0. Then what other thing can I cancel? I've got negative x and x here, so those ones will also go. Okay, then what do I remain with? So I'm going to remain with the limit as h is approaching 0. On top I've remained with 2h plus h squared plus h, everything over h. Okay, so now what do I have? Allow me to rub on top. What are we going to now finally have? We're going to have the limit as h is approaching 0. This is f prime of x. Now we've got this expression on top. So allow me to factorize the h, because our goal is to cancel the h. So I'm going to have h outside. I'm going to remain with a 2. I'm going to remain with a 2 plus h plus a 1. Okay, then down we have h. Okay, now what do we have? The h and the h can divide. Okay, the h and the h can divide. So what are we now going to have? 2hx. This is 2hx. This one was 2hx. So I'm going to remain with a 2x there. So what do we now have? We are going to have the limit as h is approaching 0. On top we've remained with 2x plus h plus a 1. Now that we've got this expression where there is h, we're going to replace by 0. Okay, so therefore it is going to be 2x plus a 1. That will be our final answer. So this is where we end from for today. See you in the next session.